In this lecture, we will explore the world of thermal analysis, its sorts of techniques used to understand how materials behave when heated. We will delve into a specific technique called thermogrammetric analysis (TGA) and see how it provides valuable insight into a material's composition, thermal stability, and decomposition process. There is the main content of this video. First one is introduction of thermal analysis methods, principle and instrumentation, TGA, DT, DSC, and applications. What is thermal analysis? Thermal analysis is a group of techniques that measure the physical or chemical changes of a material as a function of temperature or time. It provides information about decomposition, melting, crystallization, glass transition, and more. The thermal analysis techniques are widely used in various fields like polymer sciences, material sciences, pharmaceutical science, and forensics. Thermal analysis is a powerful umbrella term and comprising of various techniques that unveiling the material's secret when heated. By monitoring changes like weight, heat flow, or dimension, we gain insight into various thermal events the material undergoes. These techniques find application in diverse fields from designing new polymer to analyzing the drug stability, even solving forensic puzzles. In this graph, you can see here on the y-axis weight percent and on the x-axis there is the temperature range, and there is a deviation on the right hand side, deviation in the weight percent degree Celsius. Here in the above we can analyze here the graph. Starting it is decrease up to 100 degrees Celsius. With the control condition, we can find out where any molecules are evolved. On the basis of thermal analysis, we can categorize it into the different category. First one is thermogrammetric analysis. It measures the mass change of a sample as a function of temperature and helps in identify the decomposition, evaporation, and absorption of moisture. Second one is the differential thermal analysis (DTA), which measure the difference in the temperature between the sample and an inert reference material as they are heated or cooled under the same condition. By flow of heat, we can find out the melting, crystallization, and phase transitions. Third one is differential scanning calorimetry, and it means DSC, which measure the heat flow between the sample and the reference, provides more detailed information about the enthalpy. It means heat absorbed or released during the thermal events. And next one is thermomechanical analysis (TMA), which measure the dimensional changes like the length, volume of a sample as a function of temperature. With the help of this technique, we can find out the stress and its thermal expansion or contraction behavior. Beyond these technique, we can also identify two more technique: evolved gas analysis (EGA) coupled with the TGA with the gas chromatography or mass spectrometry to identify the gas evolved during the decomposition and other thermal events. Next one is dynamic mechanical analysis (DMA), measure the mechanical properties, elasticity modules of a sample in a controlled temperature conditions. So what are the application of thermal analysis? First one is material characterization. With the help of these technique, we can characterize the purity of the sample, thermal stability of material like polymer, pharmaceutical products, and ceramics, etc. In reaction monitoring, by using of this analysis, we can analyze the kinetics and thermodynamic parameters. Decomposition studies. With the help of this technique, we can find out the decomposition temperature of any particular substance. In the phase transition, we identify the temperature at which material undergo changes in their physical state, like solid to liquid or liquid to solid, and so on. So, with the help of this technique, we can utilize various things. Next technique is first one is a thermogrametric analysis. What is thermogrametric analysis? It measures the change in mass of a sample as a function of temperature or time in a controlled atmosphere. The instrument consists of a furnace, a sample pan, and high precision balance. The sample is heated according to programmed temperature ramp and its weight is continuously monitored. A TGA plot, also known as thermogrametric curve, is generated showing the percent mass on the y-axis and temperature in degrees Celsius on the x-axis. Thermogrammetric analysis, often abbreviated as a TGA, is a workhouse technique in thermal analysis, and it offers a straightforward approach. We monitor a sample weights as we heat it up. The instrument is elegantly simple with a furnace to control temperature, a sample pan holder, a sample pan holder, and hold the material of interest and a high precision balance to detect the slightest change in mass. As the temperature rises, the sample might undergo various events like loss of water molecules, decomposition of small fragments, each even in reflecting as a change in the sample of mass, which is plotted as a TGA curve. This curve become a fingerprint telling us the story what happening to the material as heated is applied. Basic principle of the TGA is that it measures the amount or the rate of weight change of a material with respect to time or temperature. Okay. And what is TGA thermogram? A plot of mass percent as a function of time or temperature. That is thermogram. And TGA are two types, static and dynamic thermogrammetric analysis. Static means if we analyze any sample at a constant temperature for a period of time during which any change in weight are observed, that is static or isothermal. Iso means constant, and dynamic thermogrammetric analysis means motion, moving. It means sample is subjected to condition in a predetermined, carefully controlled, continuous increase in temperature. And here is one another term is thermogram, that is TGA curve of a single stage. It is a single stage weight percent with temperature in degrees Celsius. The initially Ti, here up to here there is no change in the mass. After more increase in the temperature, there is a finally change in the temperature. So if we find out the decomposition like Ti minus Tf. TG instrumentation. Instrument is thermobalance data recorded in the form of curve as a thermogram. Three major part: a sensitive analytical balance range up to 100 milligram. Second one is furnace where heating device temperature. Third one is unit for temperature measurement and control. Next one is a recorder. This is a different part. First one is balance. In the figure you can see the balance. It measure accuracy, sensitivity, responsibility, capability, and there is the two type of the balance: deflection type and second one is the null type. Second is the furnace. Furnace and control system must be designed to produce linear heating at a whole working temperature range of the furnace. And the temperature range is 150 to 2000 degrees Celsius. It is a furnace. Next one is recorder. Recorder both temperature and weight continuously and make a definite period record of a time. Thermogrametric curves. This curve is made between person mass and the temperature in degrees Celsius and also measure in the deviation in the mass with percent. With the dotted line, you can see here the deviations. The TG curve present the variation in the mass of the sample with temperature over time, and DTG is the curve in as you can see the dotted line. We take one example of the calcium oxalate monohydrate, and formula is CaC2O4 with one water molecule. When 100 to 250 degrees Celsius, first stage is occur and there is a loss of water. In the second stage, further 400 to 500 degrees Celsius, further heat and here CO2 gas is removed and the calcium carbonate is left. Further on heating from 700 to 850 degrees Celsius, calcium oxide we will got. This is the simple reaction for formation of calcium oxide from calcium oxalate monohydrate. Advantages and disadvantages. TJ is a high accuracy of the balance used as well as precise control of heating, cooling rate and atmospheric condition. Second one, TGA may be convenient and time saving. Performance of technique does suffer due to construction requirement. Any type of solid can be analyzed. Fast heating rate with good resolution can be maintained. In TGA, one can hold the furnace at 1000 degrees Celsius without any balance drift, which is not balanced in other thermobalance. There is some disadvantages of the TGA. Very small amount of sample are used, but non-homogeneous sample cannot be tested. Sensitivity to heating rate and sample mass result in the shift in temperature, limited to sample which undergoes the weight change. Data interpretation is not always straightforward. These some applications. First one, purity and thermal stability. Solid state reactions, oxidative reductive stability. It measures the pyrolysis of coal and petroleum and wood, and also find out the reaction kinetic study. Even pyrolysis of coal and petroleum and wood may also be measured. So these are the few so many application of TGA. Thank you so much.